In this video, I'd like to take a look at identifying signs, SIG and S, of trig functions according to quadrants in the plane. Recall that the quadrants are numbered quadrant 1 in the upper right, and we go counterclockwise through quadrant 2, 3, and then finally 4 in the bottom right. So, where's cosine of theta positive? On the unit circle, cosine of a rotation is identified with the x-coordinates. The x-coordinates to the right of the y-axis are positive, so cosine of theta is positive in quadrant 1 and 4. X-coordinates are negative to the left of the y-axis, so the cosine is negative in 2 and 3. What about the sine of theta? Sine of theta on the unit circle is identified with y-coordinates. The y-coordinates are positive above the x-axis, so the sine of theta is positive in quadrants 1 and 2, and certainly sine will be negative in 3 and 4. Okay. Now the other trig functions, tangent of theta, which is sine theta over cosine theta, cotangent theta, which we can think of as cosine theta over sine theta, or 1 over tangent theta, secant, which is 1 over the cosine, and cosecant, which is 1 over the sine. The SIG and S of these 4 trig functions can all be identified just by looking at whether or not sine and cosine is positive or negative in a given quadrant. For example, tangent theta. Where is this going to be positive? Well, tangent theta is the sine over the cosine. So wherever sine and cosine are both positive or both negative, we will get a positive result for tangent. Well, sine is the y-coordinate, cosine is the x-coordinate. X and y coordinates are positive in quadrant 1, and they are both negative in quadrant 3. So in those two quadrants, y over x, or the sine over the cosine, will give us a positive number. Okay. In quadrant 2 and quadrant 4, the x and y coordinates have different signs, so in these two quadrants, tangent of theta will be negative. Okay. And we can work with the other 3 trig functions, just looking at the positive or negative nature of sine and cosine.